This is lesson 4.5 on connecting fractions, decimals, and percents. Before watching the recording, please make sure that you have either your math journal or a graph sheet of paper or a sheet of paper with you. Make sure you have a pencil, an eraser, a ruler, and perhaps some different colored pens and highlighters along hand as well. So if you need to pause the recording to get these items, please do that now. Also, take the time to pause the recording so that you have today's date written down at the top of your page, the lesson number being 4.5. And we're going to start off with a quick review of last lesson 4.4. So we talked about percents and the definition and meaning of percent. So percent we connected to the previous topic on ratios because a percent, if you remember, is a ratio out of 100. And if you actually break down the meaning of percent and the root of percent, per, it means per 100, cent meaning 100 in French. So those are just reminders of where percent comes from. I'm going to continue here. So also note that fractions, decimals, and percents are three ways to describe parts of a whole. And this lesson will explore the connection between fractions, decimals, and percents. And we're going to move away from always dealing with fractions over 100, which is what we dealt with in the previous lesson. Now, again, we're looking at the ways in which these three elements are connected to describe parts of a whole. And so what you only have to be concerned about so far at this point are fractions whose denominators have 100 as its multiple. So it's easy to calculate and easy to convert the fractions that you're being given into fractions or the percent, essentially, per 100. So what do I mean by that? Well, let's call them nice fractions. And these are the only ones you have to deal with, again, so far at this point, okay? So the nice fractions you have to deal with, and maybe you can start seeing this connection now, are, let's start with, well, something over 2. So I'm actually going to put x as the numerator in all of these cases. So the nice fractions where, and I'll define this here, where the denominator has 100 as one of its multiples. And notice that we always bring back the language from previous units because everything always builds on top of each other in math, right? So again, nice fractions, and let me highlight that, nice fractions, where the denominator has 100 as one of its multiples, so it's easy to convert it or get the equivalent fraction over 100. So the first one is x over 2, and actually, I'll go back to a pencil here. So anything over 2, easy to multiply by 100 because if you think about it, all you're doing is you're multiplying the denominator here by 50 to get to 100. And I'm going to do that in a different color. Okay, now as I'm moving along these nice fractions, and if you want to think to yourself how many times do you need to multiply the denominator to get to 100, then I encourage you to pause it, jot it down, and check your answer. The next one is x over 4, so quarters, right? So you think to yourself, how many times do you have to multiply 4 to get to 100? If I think about quarters, I know 4 times 25 will get me to a fraction over 100. And then I'm moving on. Okay, x over 2, x over, I think the next one is, x over 5, so fifths, right? So again, 5 has 100 as one of its multiples. Think to yourself, how many times do you have to multiply 5 to get to 100? I know it's going to be 5 times 20. Now, if at this point you're still confused, don't worry about it. It will make more sense as we apply these to certain questions. I'm just going over all of these fractions again, who has a denominator that has 100 as one of its multiples. So moving along. So x over 2, x over 4, x over 5. I think the next one is x over 10. Now, again, how many times do you multiply 10 to get to 100? I know it's going to be 10 times 10. That will give me 100. The next one up from there, 15, 20. So I believe it would be x over 20 would be the next one. Again, how many times do you have to multiply 20 to get to 100? Notice how it's reducing now from 2. I know that 20 times 5 will give me 100 because it's the same as 5 times 20. The next one from x over 20, I believe the next one is x over 25. If you look at x over 4, how many times do you multiply 25 to get to 100? I know it has to be 4 times. And then x over 25, I know that my last one, I believe, will be x over 50. So anything over 50, that's more of a straightforward conversion. 50 times 2 will give me 100. So if, again, the numbers in blue here that I've multiplied by indicate how many times you need to multiply the denominator to get to 100. So again, calling them nice fractions because they're easy to convert to a fraction over 100, which is what you need to do to get its percent. Okay, so let's see how these apply in certain questions. Okay. Suppose I gave you one question like this, and let's work through examples here. Okay, let's go with a different color. Example, we'll go to green. Examples. So, write as a fraction. Oops, sorry, not write as a fraction. Write each fraction as a percent and as a decimal. Okay. So again, if you're given a fraction and you have to convert it to a percent and a decimal, at this point, you just have to worry about the nice fractions. So I'll give you a nice fraction. So let's start off with 7 over 10. Now, 7 over 10, if I know that I need to convert it to a percent, I know a lot of you can jump probably to the percent right away, but let's take the steps to get there. So if I look at my chart here up above of my nice fractions, I know that a fraction over 10, if I want to convert it to a fraction over 100, all I need to do is I need to just multiply the denominator by 10. If 10 times 10 will give me 100, whatever I do to the bottom, I have to do the top or the numerator. So 7 times 10 would give me 70 over 100. So I know 7 over 10 is the equivalent to 70 over 100. Therefore, I know its percent is automatically 70% because percent means per 100 or ratio of it out of 100. If you remember from the previous lesson too, if you think about the hundredths grid, what does 70 over 100 represent is represented as a decimal? I know it's 70 hundredths. You could also express it as 7/10. That's also acceptable. Okay, so again, as a fraction, it's 7 over 10. You find out what the equivalent fraction is over 100 because percent means per 100. Again, I would actually box this out as a nice little chart just so you have it as a reference so that you understand clearly how many times you have to multiply each denominator by to get to 100. Okay, so that's how we apply this chart here. Okay, let's go with another example. That was example number 1. Okay, example number 2. So let's say we had 11 over 20. Okay, again, same process. You're going to write this fraction as a percent and as a decimal. So the first thing we have to deal with is that it's not over 100. We know that 20, again, is one of our nice fractions because 100 is a multiple of 20. So we're going to set it up as an equivalent fraction here. So how many times do you have to multiply 20 to get to 100? Well, I know it's going to be 20 times 5. And again, I should say feel free to pause the recording at any time if you want to figure out the questions yourself and then check the answer when you're ready to check your answer. Again, whatever you do to the bottom, you have to do the top of the fraction for the equivalent. If 20 times 5 is 100, then I know 11 times 5 is 55 over 100. The equivalent percent, because percent means per 100, will be 55%. Again, it also makes it a nice conversion to the equivalent decimal form of 55 hundredths. Okay, so those are 2 examples dealing with fractions that aren't necessarily over 100, but it's easy to convert to 100 because, again, these denominators have 100 as its multiple. Okay, let's go to some diagrams here. So example number 3, actually, let's move on to a different color here because I want to just give you a different question. Let's do blue here. So here's a third example, and I want you to do is think about what percent is shaded. So let's do, I might have gone too far. Maybe just wait until I finish this here. Okay, so 1, 2, 3, 4. Yeah, I went a little bit too far here. Oh, it erases the whole line. Okay. That's what I meant to do here. Okay. Okay, what percent is shaded? So if I did this, okay. So what percent is shaded? Now, again, if you want to pause the recording, figure out what percent is shaded, and then replay the recording to check your answer, go ahead and do that. But I'll walk you through the steps and how to figure this out. So the first thing to do is figure out, well, how many parts is this divided into? So I know I've got 1, 2, 3, 4, 5 parts. Okay, so I know since this diagram is divided into 5 parts, I know it's going to be divided into fifths. So how many fifths are shaded from this diagram? 4 out of 5 have been shaded. So now if we know 4/5 have been shaded, we know that we can convert 4/5 into a fraction over 100. So we're going to follow the same process as before. Again, think to yourself, how many times do you multiply 5 to get to 100? Because 100 is a multiple of 5. I know if I multiply 5 by 20, I will get 100. Again, whatever you do to the bottom, you have to do the top or the numerator. So therefore, I know that 4 times 20 will give me 80 over 100. Therefore, since it's 80 over 100 and percent means per 100, 80% of that diagram is shaded. So that's how you would work through a question like that. Just thinking of more examples here. Okay, so another example that you could be given is this. So I know I keep jumping colors here because it's a different kind of question. Let's go to this here. So another example of how this goes into it is convert to a decimal and a fraction in lowest terms. So this is, again, good practice for divisibility rules as well and common multiples. Okay. So say, for example, you were actually given 24%. And you were asked, okay, convert 24% to a decimal and a fraction in lowest terms. Okay. I know that 24% as a fraction, because it's per cent already, means per 100, I know that automatically is going to be 24 over 100. I know that that's the equivalent fraction over 100. Therefore, I know that as the decimal, it's 24 hundredths, okay? Now, it does say to convert the fraction to lowest terms. So how do we do that? Well, we take 24 out of 100. Oops. And then think to yourself, okay, well, if I can't jump to lowest terms right away, I always think of divisibility rules, right? So what is the numerator and denominator both divisible by? And again, if you want to pause the recording, figure this out for yourself, and figure it out in lowest terms, go ahead and do that. I'm going to carry on. Okay, well, I know that since both 24 and 100 are even numbers, they end in an even digit, both the numerator and denominator have to be divisible by 2. So I know that 24 divided by 2 is 12. And I know that 100 divided by 2 is 50. Okay, this looks like it probably could reduce even more. Again, think of your divisibility rules. Well, 2 is always a good one to go with. Although it takes longer, it's a good one to do. So I know that both are divisible by 2 again because they are ending in even digits. 12 divided by 2 is 6, and 50 divided by 2 is 25. Now, it doesn't look, and I think to myself, okay, is there anything in common that's divisible by 6 and by 25? Well, no, because 25 looks like it's only divisible by 5, and 6 is an even number. So we've reduced 24% to a fraction in lowest terms to 6 over 25. We know the equivalent decimal is 24 hundredths. So what's the process here when you're given a question like this? What you would do is you would have to put it, put the percent as a fraction over 100, and then reduce to lowest terms. Then reduce the fraction. Again, I'm going to put a note here. Remember your divisibility rules. This is where it all comes into play here again. Okay, so that's another example of a question. Let's do one more here. Okay, so let's go with the same sort of question here, where you're given, I'm just trying to think here. Okay, 76%. So similar question as above. I want you to convert 76% to a decimal and then as a fraction in lowest terms. So you can follow the same process. Let's call this 4A and let's call this 4B, okay? So again, pause the recording if you'd like to figure it out on your own before you check it. So I'm going to continue. So remember our steps. You're going to put the percent as a fraction over 100. Then you're going to reduce the fraction. So 76% as a fraction over 100 is 76 over 100. I know automatically if something is over 100, it's easy to convert to the decimal. So I know it's going to be 76 hundredths. So knowing that, again, we know that 76% is 76 over 100. And I'm thinking to myself, okay, I need to reduce this fraction. Again, it looks like we have two numbers that end in even digits. So I'm going to reduce it. I'm going to go 76 divided by 2. 76 divided by 2. Have to do a bit of work here. So 100 divided by 2 is, what is that? 50. 76 divided by 2. I have to do some thinking here. 76 divided by 2 would give me 38 over 50. Okay, now, I've got 38 over 50 here. It looks like it could reduce even more, so I'm going to go divide by 2 and divide by 2 because I know both of them end in an even digit. 38 divided by 2 would give me 19, and 50 divided by 2 would give me 25. So 76% as a fraction in lowest terms would be 19 over 25. So in terms of what we've been talking about, let's just review and recap here. We talked about percents again and how the percent is key to understand that percent means per 100 or a ratio out of 100. Fractions, decimals, and percents are 3 ways to describe parts of a whole. The focus here was on the nice fractions because when you're dealing with fractions and you have to convert it to a decimal and a percent, you're given the so-called nice fractions, meaning the denominator has 100 as one of its multiples. And we have identified at least 7 of them that you'll be dealing with. So we came up with examples here where you're given the fraction and you have to write it as a percent and as a decimal, okay? What percent is shaded? So again, not necessarily out of 100, but you can easily convert it to a fraction over 100 and then convert the percent. Another example is when you're given maybe a percent, and you could be given the decimal as well, and you're asked to convert to a decimal and a fraction in lowest terms. The decimal is easy to come by because automatically whatever that fraction is over 100 is equal to the decimal, 24 hundredths in this case. And then when you're reducing fractions, think of your divisibility rules, right? We know that we're going to start off with a fraction over 100 if it's a percent, and then just keep reducing it until you can't go any further. The numerator and denominator don't have anything in common in terms of divisibility. So those are things to keep in mind when you're working through these questions. Also, one other thing that you could come across is something like this. So, okay, I'll give you one more example here. Okay, let's do dark purple here. Okay, so number 5. So, I want you to order the following. From least to greatest. Okay, now, again, I encourage you, pause the recording if you want to, before checking your answers. So, here we go. We've got 43%. I've got 4/5, and I've got 66 hundredths. Okay, so you're going to order the following here from least to greatest. So a couple of issues here. So the first thing is, well, you've got 1%, you've got one fraction, and you've got one decimal. So you need to pick something where they're all in the same format so you can easily compare them. So what I'm going to do is I'm actually going to change everything to a percent. Now, you don't have to do the same thing that I'm doing, but I'm just choosing percent because I see 43% is already a percent. I'm going to leave 43% as it is, okay? Now, in a question like this, you'd have to show your work. I know 4/5. I can get this to a percent, okay? So 4/5 as a percent, well, I know that 5, how many times do I have to multiply 5 to get to 100? Well, I know that 100 is a multiple of 5. It's going to be times 20. Whatever I do to the bottom, I have to do to the top. So I know it's 80 over 100, which equals 80%. Well, the other piece is 66 hundredths. Now, again, in a question like this, the expectation would be that you have everything in the same format, and then when you order it, they're all in the same format and you're showing your work. I know 66 hundredths automatically is 66 over 100 because of the decimal equivalent and the hundredths grid, because it's 66 hundredths is less than 1 whole. So I know as a percent, it's going to be 66% because percent means per 100. I can see now that from least to greatest, this is number 1, this is number 2, and this is number 3. Okay. Now that I've done my work, I'm going to go back to the original. I'm going to say that 43% is the least, and I'm going to go back to the original format. I know that the next greatest is going to be 66 hundredths, and I know that the greatest is going to be 4/5. And that's how you would tackle a question like that. Okay, and that is it for the lesson on 4.5.